In this video, we're going to go through soundings, especially from the aviation with a forecasting perspective. And the first thing we're going to go through is the condensation trails or the contrails and the formation of those. You can tick on the helper lines from the settings. So here we have option to choose condensation trail help lines. And when you tick it on and click OK, you get these orange lines visible. And the concept here is fairly easy to understand. So we have 4 helper lines, 0, 40, 70 and 100. And they are relative humidity lines basically. So if the humidity is 70% and it's colder than this line is indicating at some level, the condensation trails could be happening. So let's take an example. These numbers are according to this sounding we are currently observing. So here we have a value of 100% and we are on the colder side of this 100% helper line. So it means that at this level, the condensation trails could be forming. So we can take another example. So if we, for example, consider the level of 8 kilometers, it's around here. And we can see a value of 83% in this layer. And if we now consider, we can draw imaginary 80% line here on the right side of this 70%. And if we think that the temperature in this layer is not on the colder side of this 80% helper line, the condensation trail won't form. So these orange lines are telling you that how cold it should be when considering these relative humidities so that the condensation trails would form. The next thing we can consider is the height of the cloud top. So this is especially related into cumulonimbus clouds that are producing or are not producing thunderstorms. So we need to be able to forecast the tops of these clouds. And here in this example that we had before, I can see that the cloud top is where the equilibrium level is. So here it's around 10.5 kilometers or in flight levels 350. Let's take another example. So here we have cloud top height of 9 kilometers or flight level 300, theoretically. Because according to the sounding, it might not be the best sounding for the initiation of the convection. But anyway, if something happens, the cloud top would be here where the equilibrium level is. On the other hand, here, our cloud top would be around 11 kilometers. So flight level 370 almost. And remember, if we have a lot of dry air entrainment might reduce the amount of cape, so that's why you might need to lower down this just a little bit in your heads and not just blindly trust what this most unstable cape profile is giving you. We also want to consider low-topped cumulonimbus clouds. And here is an example of that. So you can see that we have an extremely narrow area of cape here. But still, we have some cape, which means that it's a convective cloud. And this convective cloud top is around here, so around 3 kilometers, which is flight level 100. The top temperature is not below -20, so it's probably not going to produce any lightning. But still, from the aviation weather perspective, these kind of low cumulonimbus clouds are important to forecast. Also, bottom of the cloud is important to forecast, and if we are considering convective clouds, the bottom of the cloud is at liquid condensation level, so LCL, and it's basically where this green curve is going to make this transition from dry adiabatic lapse rates to moist adiabatic lapse rates. So that's the level of convective cloud bottom. We can take a look from this example again. So here the LCL is actually marked and it's here at this level, so flight level 40 or just above 1 kilometer. If you have stratiform cloud, then your cloud bottom is here, so the lowest height you can find clouds from. And if you have a layer of clouds, you are probably considering the height of a ceiling. Also in the aviation weather, people are very interested in direction of upper level winds. This might be important for some customers, but also the direction and the strength of the wind is important anyway if you are considering turbulence. So when we are considering turbulence, we need to pay attention to the change of the wind, both in direction and in strength. So we are talking about vertical wind shear. And here you can quite well see how the wind is intensifying the more we go higher up in the atmosphere. But the direction is not changing that much. Here is another example with velocity wind shear. So the speed is intensifying a lot, and then again the wind speeds are decreasing a little bit, and then they are speeding up again. The direction is not changing that much, but the velocity is. Here we have a little bit of change in the direction of the winds. So first we have westerly or a little bit of westerly with a hinge of northern component, and then the wind direction is changing to be more southwesterly. So here we have directional wind shear. And since our winds are backing, this is actually an indication of cold air advection. The next thing is the icing inside a cloud on the aircraft. So icing happens when we have liquid supercooled water particles present in the cloud. And this usually happens when we are on the colder side of the zero isotherm, and especially between 0 and -12 degrees Celsius. So any cloud layers within this range are considered icing. And if we have a frontal cloud, like we have in this example now, icing or freezing can happen all the way up to -20 degrees Celsius. So here we have quite a deep icing cloud layer. We can take another example as well. Here we have very nice warm front cloud, and it's freezing all the way from the bottom to 5 kilometers. And even above that, it's possible, but it's not that big of a threat anymore. So the most of the freezing is happening in this layer. In aviation, we are also considering the height of the tropopause. So we need to be able to forecast that as well. In SmartMet, you can see tropopause quite easily when you are just looking at the temperature profile. So usually your temperature is cooling down when you are going higher up in the atmosphere. But the moment you hit the tropopause, your temperature starts to increase or stays the same. So here the tropopause is around 9 kilometers. But it could be higher, it could be lower, depending where you are. And also depending on the time of the year. So during the summer, tropopause heights are typically higher up, and during the winter time, it's lowering, and it could be, at least in Scandinavia, it could be all the way down to 4 kilometers, so it could be very low. So we can take an example. Here, the tropopause is around here, so 11 kilometers. And in this sounding, it's here, 11.5 kilometers. It's actually quite high. And sometimes SmartMet is also able to indicate you the location of the tropopause with the letters TR. And here, it's around 9 kilometers. Here, between 8 and 9 kilometers. But above all, the golden rule in aviation weather forecasting is always to consider and pay attention to the change of the situation. So it's not just how things look at certain moments, but it's more like the change. Is the wind speed getting higher? Is the direction changing? Is there change in the freezing level height or the thickness of the cloud? all these things matter a lot in aviation weather forecasting.